Hi, and welcome to the third video of this series. In this video, we're going to be doing both the second normal form and the third one. Why? Because we already have everything prepared. We just need to separate out our tables and form relationships between them. So let's jump right into it. The first thing we need to do is carry out everything the second normal form tells us to do. So the second normal form tells us to separate partial dependencies. And if you saw the last video, you know that all of our partial dependencies are right here. And they also can be defined with arrows such as these. So let's jump to what they look like separated. So here are the partial dependencies written out here. And down below, we have the tables separate. Now, what I want to do is show you how this can be done in purely text form. And for the text form, we need to have all of our attribute names. So let's jump into Sublime and go to editing. Now, what I like to do is separate all the IDs to the front. And I usually create this and label this as my first normal form, where I have these IDs affecting these attributes. The other thing I like to do is find the transitive dependencies if I have them and nest them in one more layer of brackets. So then I know that even though these are my IDs, I have a transitive dependency within them. Now, this is just something I do on paper and something that helps me a lot. So when I'm doing my second normal form, and when I'm trying to get these kind of tables, I first do the drawing of the arrows, like in here, and then with this drawing to help me, I then write out all the tables that are going to be formed. So all the IDs are going to have their own tables in most cases. And there are going to be cases where two IDs have their own separate table. For us, this is the case with quantity. We have transaction ID and we have PID. So PID, copied once more, with transaction ID. And the last thing we have to do is get all the attributes that transaction ID uniquely identifies on its own, get all the attributes the pet ID uniquely identifies on its own, PID uniquely identifies on its own, and PID and transaction ID identify. I also like to keep the notation of my transitive dependency if I have it already figured out. And there we go. This is my second normal form. Once we have this, the table separated out and no partial dependency in the same table, our second normal form is pretty much done. Now we move on to the third normal form. And you'll see that the third normal form from all of these is probably going to be the easiest if you define the dependencies right away in the first normal form. Now, the only thing we'll need to do is carry this dependency out and define it like this. However, a first name and last name could be repeating, and you might have thought of this already. So we should add in this table some kind of owner ID. Now that we separated out our transitive dependency, we have the final tables right here. Now we need to make an ERD for this.
Now you'll have to focus on my voice a bit. I'm doing this post-filming because I was not satisfied with the explanations I gave building this ERD. This is why you'll see that the video is sped up, but don't worry, I'm gonna explain what I did exactly even better than I did when recording the video. Now, firstly, a disclaimer, I said I will do optimizations later on in the fourth video, but during the drawing of this ERD, I already added two attributes, which should be there. Should be there in the clean third normal form, but if you optimize, you can add them. These attributes are IDs, the invoice ID, INV ID, and the owner ID, OW ID. Now, I just find it nice to include an auto-incrementing number in all tables, and I will probably preach about this in all of my database tutorials. So I won't waste any more time on it, but if you go back and look at our clean third normal form, it doesn't include these attributes. As far as regulating relationships go, you'll need to take a look at the zeroth normal form that we had in the spreadsheet, and you'll have to look which details we had. It is good to have some experience with drawing ERDs and of course good knowledge on how to formulate business rules. Once you draw all the tables, you can start working on business rules such as this. Each owner can have many pets, and the other direction, each pet can belong to only one owner. Once defined, we can return to the zeroth normal form to check and see if that makes sense and works for our system and the requirements we have for it. After checking and confirming, we just implement it as a one-to-many relationship that it is. Some tables, such as invoices in our case, can have multiple solutions. We could have linked owners to it directly by one-to-many relationships without ever linking pets at all. But this approach of linking owners without pets would make us lose the details that we had in the zeroth normal form. And that's the detail of which pet had what procedures carried out on it. So that leaves the choice of only including and linking pets directly or having owner there too. I left it with only pets because we can figure out the owner using a join in a query or a view. So what I'm trying to say, and what's the main takeaway from this, is that you need to check all the relationships you make so they really correlate to the system. And I'm trying to highlight that drawing ERDs is a good skill to have, and thinking about relationships is a good skill to have, because you will need to formulate business rules and validate them once you're done drawing. So that's it, and we can continue.
And if you did the relationships correctly, a good way to check if you set all the foreign keys in place is to see how many manys are connected to that table. In the case of pets, we only have one, so we have one foreign key. In case of invoices, we have three, so we'll have 3 foreign keys. In case of these other 3 tables, we don't have any many relationship connected to it or to them, so we don't have any foreign keys within them. You can join me in the next video where we optimize this database and we reduce the number of tables and relationships because you'll see that there is more than enough information to make this database work with even less tables. So that sums it up for the normalization and the second and the third normal form, because we finished right here. I hope you learned something and I hope you enjoyed this process. Thank you all for watching and see you in the next one.